Good morning, students. Today we are going to discuss the next section of vector algebra. So till now we have studied about the representation of a point and parallelogram theorem for summation and same extension for differences. We have discussed about the dot product and cross product and various different problems like unit vectors we have discussed. So now we are going to discuss the next section of the vector algebra. So here we will go. Now, see, already we have discussed like unit vector used to decide, unit vector give the direction. Unit vector provides the direction, correct? Because its magnitude is 1. Like if there is a vector, a vector, if we want to calculate its direction, then we call it as a unit vector that we used to give a vector divided by mod of a vector, correct? So till now we have seen this. Now sometime question used to be asked in exams, like we have to find a vector of magnitude, let's suppose 7, of magnitude 7 in the direction of a vector, and a vector has been given something like this: I plus j minus k. So here we are having a vector a, and we have to calculate another vector whose magnitude is 7 and is in the direction of a vector. So you see, a vector is having a magnitude of what? A vector is having a magnitude of 1 square plus 1 square plus minus 1 square, that will be square root of 3, correct? So this is the magnitude of A. So if we want to calculate another vector whose magnitude is 7 and we want to calculate the direction, then you see, if a vector is having a magnitude 7 and its a direction, let's suppose it is x cap. Okay, so you see vector magnitude is 7 and its direction is x cap. So magnitude already available in the question, but we require direction. So direction, and question is saying direction should be in the direction of a vector. So if we calculate the direction of a vector, then we will call it as a unit vector of a vector. So you know, unit vector of a vector can be written as a vector divided by modulus of a vector, correct? So we will write it I plus j minus k divided by square root of 3. So this is the unit vector. Unit vector means this is the direction of a vector, and if you calculate its magnitude, you will get 1. So a cap magnitude will come as 1. So this is unit vector and it is a direction only. So now if we want to calculate the vector whose magnitude is 7 and is in the direction of a vector, then our answer should be, let's suppose this is the b vector and its magnitude is 7 and direction is whatever direction of a vector is there. So I plus j minus k vector divided by square root of 3. So this is the actual vector that is required by us. So if you calculate its magnitude, you will get 7 as magnitude, and direction is I plus j minus k divided by square root of 3. So sometimes this type of question used to be asked. So we have to be careful about the unit vector, how to calculate the direction. Okay, so next topic is projection. So this is very important topic, and we will talk about projection of a vector. Projection of a vector on another vector. So we will have two vector here. Let's suppose this is the vector A. Okay, and we are having another vector that is B. This is my B vector. So sometime question used to be asked, what is the projection of A on B, or what is the projection of B on A? So we will discuss about first projection of B vector onto A vector. Okay, actually this is coming from the part, like if we are having one force that is applied in like this is my force and this is my ground, and this is making an angle of theta degree, then what is the projection on the horizontal side? So it is f cos theta, correct? And what is the projection on vertical side, though? In we can write like f sin theta, correct? So same part we are going to do with the vector. because already we know vector is force is also a vector. So let's suppose these two vector a vector and b vector are making an angle of theta degree with respect to each other. So if we want to calculate the projection of b on a, let's suppose the magnitude of b vector at this point is modulus of b. So what is the projection on a vector? So it is modulus b cos theta, correct? And you know, if we want to calculate the dot product of these two vector a vector dot b vector, it will give modulus of a vector into modulus of b vector cos of theta, correct? So if I want to calculate the value of cos theta, then I will write a vector dot b vector divided by modulus of a vector and modulus of b vector. You already know a dot b is always a scalar quantity. So scalar divided by scalar is going to be a scalar, and we know cos theta must be a scalar only. So this is the value of cos theta. Now we have to calculate projection of b onto a. Okay, so projection of b onto a is written as projection of b onto a. So keep in mind, this is the meaning of projection of b onto a. So it is something like log type of thing. So projection of b onto a. So it will be written like this. So projection of b onto a, if we want to write mod b cos theta, but what is the direction? Direction is a cap, correct? Because we have to calculate in the direction of a vector. So we can write mod b cos theta, and a cap, how to calculate? You know, a cap is nothing but unit vector of a. So this will be the unit vector of a, because we have to talk about the direction. Actually this is the direction, correct? So this is the direction of a, direction of a vector. So if I have to calculate this one, then I can write mod b vector cos theta, I can write like this. So this is going to be a vector dot b vector divided by mod a mod b and a vector divided by mod a. So mod b is a constant quantity, is a scalar quantity. We can deduct, we can just cut it like this. So we can write it like this. So projection of b on a can be written like this, like this. So projection of b onto a can be written as a vector dot b vector divided by mod a vector square into a vector, correct? So this is the projection of b onto a. Clear? So this is projection of b onto a. If somebody wants, no, I want projection of a onto b. So projection of a onto b can be written as, this part will not change, you see, this part will not change. So what will change? Here it will be b, here it will be b. So it will be a vector dot b vector divided by mod b vector square into b vector. See, a dot b is going to be a scalar quantity, mod b is going to be a scalar quantity, scalar multiplied by a vector is a vector quantity. So this is a vector quantity, correct? So this is the projection of a onto b. So similarly, projection of a vector or b vector can be calculated. Okay, so symmetry you can follow. So this is about the projection of one vector to another vector. So it is similar to whatever force and velocities we used to discuss, like if force is applying at 30 degree or 40 degree, what will be its horizontal component and what will be its vertical component. So similar section we can apply for the vector also. Okay, now next topic is section formula. Section formula. What is the meaning of section formula actually? See, let's suppose this is my coordinate system. There is a point P and another point Q in space. This is the point P, this is the point Q, and this is my origin. So if I want to write OP vector, then this is the OP vector. And if I want to write OQ vector, this is my OQ vector. Clear? So this is my OP vector. Let's suppose OP vector is equals to A vector. OQ vector is equals to B vector. So this is my A vector, this is my B vector. So if I match PQ, so it will be something like this, a line. This will be the line. Now the question used to come, sometime we have to calculate the position vector of a point R, this is the point R. We have to calculate the position vector of this point R. That means r vector, or we can write it as OR vector is equals to r vector. So we have to calculate the position vector of r, which is dividing this PQ line into m into n ratio. Okay, so r point, or I can write OR, is dividing PQ line in m is to n ratio. Okay, so PQ line is being divided by the OR in m is to n ratio. Now we have to calculate this r vector. So keep in mind, r vector used to be given by like this. How? M into b vector plus n into a vector divided by m plus n. So this will be the position vector of the point r. I think many of the people would be knowing, because this formula you would have studied in case of coordinate system in class 10th. Okay, so where we used to have a line, that line is being intersected by a point and it is being cut it into m is to n ratio, then what is the coordinates of that point? So we used to write on the same manner. Okay, so now this was the condition when r point was lying in between the p and q. Now sometime question used to come, the r is not lying between p and q, it is lying somewhere outside. Means my p point is somewhere here, q point is somewhere here, and r point is somewhere outside. Okay, so this is your a vector actually, and this is your b vector. Okay, now this is your r vector. So if you see, this is my PQ line and R is somewhere outside. Okay, R is somewhere outside. So in that case, what will be there? R is somewhere outside and it will be written in this way. So here it is M. This is the M. Okay, and this is the N. This is the N. So you see, N is this one, and m is total distance. Total means this total distance m, and this distance is n. Okay, so it is being intersected into m is to n ratio. So in that case we will write r vector is equals to, see again you keep in mind, here r vector was in between p and q. So we are having m and n like this. But in this case, your r vector is somewhere outside. And outside means m is the total distance pr and n is the rq. Okay. So in that case, your r vector will be given as m into b vector minus n into a vector divided by m minus n. So this will be the case. So two possibilities are there. R may be in between P and Q, R may be outside P and Q. So never get confused. PR is the M and RQ is the N. So M is to N ratio. M is to N ratio is nothing but PR is to RQ. Okay. So this is the case. So these are two section formulas if somewhere asked. So you can follow this. So with this, whatever is available in the vector, we have completed. I hope this total 3 videos are there, and these videos will be highly useful for calculation the vector related problem. Thank you.